Okay.
Got it.
Good afternoon to all participants. We are here for our day 3 of our international virtual training on GIS and satellite remote sensing. The format will be the same for today as well. We'll have a couple of lectures, then a small break, and then we'll have the hands-on technical session. Um, Today we have Dr. Samiullah with us for the lectures and the hands-on training. So I'll hand it over to Dr. Samiullah now for his first lecture on satellite remote sensing and its process. Over to you, sir.
Okay, so I'm audible to everybody, right?
Yes, sir.
Okay, so I will continue. Um, okay, so Haris, they saying that my sound is not clear.
Your sound is fine, sir.
आपको आवाज आ रही है मेरी?
Yes, yes.
Okay, no, it's fine. Okay,
It's clear, it's
fine. Okay, so my name is Dr. Samiullah, and I'm working as an assistant professor, Shahid Benazir Bhatti University, Shringaldir Upper. I did my PhD in remote sensing of forestry. So basically, I'm a forester, and I'm using remote sensing for in the field of forestry specifically. So I'm also working as a co-PI of one of the ongoing projects that's actually National Center of GIS and Space Application in Pakistan. So in this project, I'm dealing independently the forest resource assessment section using remote sensing technology. That's my short introduction. So I will be with you for 4 days. I will have briefly tell you about my presentation outline. Like today, we will talk about the satellite remote sensing. Actually, what is satellite remote sensing and what is its process. And also we will do a little bit exercise like how to search, download free satellites data from different sources that we will learn today. The second day of my presentation will be like satellites image pre-processing and classification, and we'll do also a hand-on exercise on it. So today, at least you will learn how to search and download the satellite data. And from tomorrow, we'll have to know that how to process the satellite data and how to classify the satellite data into different land use, land cover classes. We'll do this will be the second day. And then on the third day, we will have, like, for example, what is land use, land cover, and its importance, and rule of GIS and remote sensing in land use, land cover classification. This will be our third day. The final day, that will be the fourth day after my presentation. Like I will talk more specifically about the GIS and remote sensing application in the field of forest sciences. That how we are applying different remote sensing data sets, classification algorithm, and space-view and space-bound sensor for different meaningful information, specifically in the area of forest sciences. This will be the fourth day. Finally, I suggest and I expect from all of you, from all the trainee, that you will at least prepare and submit a land use land cover map along with some statistic of your hometown or maybe your district, home district, or maybe your at the field level, something like that. So that will be, I expect the output from all of the training which are attending this course. So we'll go to the next slides, like the day first. In the day first, for example, we will know that actually what is actually remote sensing. So if you think about the word like remote and sensing, there are two things involved in the remote sensing. Like first is remote and the second is sensing. So remote is something like if you are sensing from remote. So actually you are not going physically to that area. You are not going, you are not physically touching that area. So you are getting information about any area on the surface of the earth, about water, about agriculture, about forest, about geology, about humans, about everything remotely. So very simple definitions like that's done by this CCR remote sensing tutorial that I got, that is the science of acquiring information about Earth's surface without actually being in contact with it. So we are getting information from any area on the surface of the Earth, and we are not going physically to that area, and we just get information, and we get this information, we are doing analysis of that information, and then finally we are getting the maps and then which go. So that's actually a very simple definition. We'll have also some other definitions later on, but that's one of the very simple definition of remote sensing. So if you go to the remote sensing data, we have spaceborne Earth resource observatory satellites. And you know that the space is completely full of nowadays a different kind of satellites. But here we are talking about the Earth resource observatory satellites, and that can be active satellites and passive satellites. So for example, the passive satellites is working on the presence of the natural energy that's actually called the sun. And also we have some active satellites which emits its own light from the satellites, and that light coming to the grounds. This reflected light go back to this sensor, and then that's detected by the sensor which is present in the satellite, and it's getting, and then we are analyzing this data. We are GIS software and for different meaningful information. We have aeroplanes different, like specifically different aircraft or airplanes with the passive and active sensor. For example, there's camera which can be fixed on an aeroplane and which can take some stereo aerial photography or aerial photography of a very high resolution, up to centimeter resolution. And then these images can be used for different applications in the field of geology, forestry, agriculture, landslides, natural hazards detection, something like that. That's fall in the spaceborne. We have spaceborne satellites and then airborne airplanes, remote sensing. We also have airborne UAV drones, for example, different cameras, which we call it sensor actually, can be fixed on a UAV drone. And this UAV drone can be fly over a specific interest area. And that images which were captured by UAV drones can be processed via different GIS softwares, and after that we will get a variety of information for different applications in the field of sciences. We also have ground-based remote sensing. For example, TLS is one of the examples of the ground-based remote sensing. For example, it can be fixed on a specific ground and it emits its own light, and the light is passing from the canopies of the forest or buildings or whatever your interest, and that light will come back to the sensor, which is detected by the sensor which is present in the TLS, and we are getting different kind of information. So specifically remote sensing data, if you want to divide, it's a kind of spaceborne sensor, airborne sensor, and ground-borne sensor. These three are the satellites, this remote sensing data. So these data finally can be added into the computers, different computer where GIS software can be installed. And these data can be analyzed with the GIS software, with different kind of GIS software. A large variety of GIS software are available in the markets for different applications. and this can be analyzed, interpreted for different information, for different applications. After analysis of this data, it's a kind of model. So we are always believing on the ground truth. So we have to do for some ground truthing, for ground sampling, for verification of our final products that we are getting from remote sensing. So our final most product will be a map of different maps. For example, if you see this map, these contain some water bodies and forest, agriculture land, and barren land, etc. We will have a classified map. So this map can be forwarded to the end user, which is a kind of a policymaker or administrator, etc. And this map can be used for different applications practically in the ground. So that's actually a general story of remote sensing, like, for example, spaceborne satellites, airborne satellites, and ground-borne. We are getting different data from remote sensing, and then we are putting the data into a GIS software using computer, and then finally we are getting the final classified maps, that which will be the end of product. So a very simple example, if you take the example of a human body, our eyes are a sensor, and our body is a kind of platform, like we have satellites. So our body carries sensor which is our eye, from one place to another. So the electromagnetic radiation are coming from the sun. It has interaction with the surface of the earth, and these radiations coming to our eyes. It's in the form of image, and this information goes to our brain, which is a kind of interpretation, or brain doing interpretation of the information, and then finally we are doing some output. We are doing some practical steps. So that's also a story. So that's the total story, but we have a variety of definitions of remote sensing, and every expert is doing the definitions of remote sensing according to his own context. For example, Sabin in 1996, he defined remote sensing that's actually the science of acquiring, processing, and interpreting images that record the interaction between electromagnetic energy and matter. So in this definition, there are two things involved. It's a kind of interaction between electromagnetic energy and matter. So if you go back, matter is, for example, that's a kind of solid, gaseous, and waters. And electromagnetic energy is sunlight. So the electromagnetic energy and matter, this interaction takes place, and this interaction is reflected from the matter, and that is recorded by the sensor, and the sensor data is converting in the form of images, and that's we are requiring, and after that we are processing these images, and we are interpreting that images for different meaningful information. So there are also another definition like resource CSR, that remote sensing is, for example, a group of techniques for collecting image or other form of data about an object from measurement made at the distance from the object and the processing and analysis of the data. So, for example, all the techniques which are involved, which is, for example, sensor, satellite sensor, computer technology, from which we get the information from a specific distance without going physically to that area, and its analysis and processing, he defined that that's actually a remote sensing. Also, there is Lily Sen and Keffer is a really famous personality in the field of GIS. He defined that remote sensing in the science and art of obtaining information about an object, area, or phenomena through analysis of the data acquired by a device that is not in contact with the object, area, or phenomena under investigation. So that's also the same definition that if you are getting information about any object, about any area or phenomena through the analysis of the data, and when you get the information or in the form of satellites images and analysis of that data, but we are not going physically in contact with that object, area, phenomena, and we are doing investigation of data images, and then we are getting different information from a distance. That's the Lillison defined the remote sensing. Also, for example, remote sensing is the instrumentation techniques and method to observe the Earth surfaces at a distance. This is also almost the same definition, and to interpret the images or numerical values, specifically, for example, when we have the satellites images, that's also in the form of pixel, and each pixel has a digital number. So when you are interpreting that images or that numerical value, when we are classifying that numerical values to get different information of land use, land cover classes, or any other point of interest, that's also a kind of remote sensing. Also, there's also some other definition, like, for example, remote sensing is the science and art of acquiring information, like spectral. So it has spectral information that is actually in the form of bits, like 1 to 56 bits and 128, and then 3 and 512 bits. Spatial actually is referred to the resolution of the pixel, that how much resolution, whether the pixel resolution is 1 meter or 15 meter and 30 meter. So we have different resolution, spatial resolution of the pixel. And temporal is like, for example, a time difference that the satellite image is available in 2000 and 2005, 2010, 2015, 2010. How much spatial or temporal or spatial resolution of the satellite images about a material, object, area, or phenomena through the analysis of the data acquired by device from measurement made at the distance without coming into the physical contact with the object, area, or phenomena under investigation. So there are many other definitions. A variety of definitions exist, and many people have defined the remote sensing according to their own context. So that's actually I gathered some of the main definition which people are using to define remote sensing. So I hope the idea of remote sensing will be clear a little bit, but when we move forward, you will get more information. Further, I would say that maybe if you have some questions, I think you can write in the text, in the chat text, and maybe after the end of lecture, we will answer one by one, or maybe we'll have a question answer section. So that's actually the definition of remote sensing. So now we are going to the process of satellites remote sensing, that how it taken place and how we are recording the data of satellite remote sensing. So if you go to the processing, in much of the remote sensing, the process involves an interaction between the incident radiations. Incident radiation is actually the radiation which is coming from the sun. So it's an interaction between the incident radiation and the target of the interest. So for example, the radiation which is coming from the sun, and then it has a specific target on the surface of the earth, for example, matter. So this is actually a process involved interaction of the incident radiation, for example, electromagnetic radiation, which is constantly coming from the sun. It has interaction with the space, it has interaction with the ground, and then it goes back, so it has again interaction. So that's actually the total process. If you can have a look to that image. For example, we will discuss this one by one, all these steps, and today our entire lecture is revolved around this image. So the sun is continuously emitting electromagnetic radiations, and these radiations come into the space, and in space it has interaction with the atmosphere, and some of the radiation reflect back, and some of the radiation passes from the space, and then it comes to the ground, and from the ground it has interaction with the matter, like some of radiation is absorbed, some are reflected, some are passed, and the reflected radiation go back into the atmosphere. So it has again interaction in the atmosphere. So and then it finally reaches to the sensor, which is sensor is present in the satellites. So and this reflected light is detected by the sensor, and this sensor convert the detected light into data or digital data, and then these sensors or the satellites send this data to the ground station. Or when sometimes there is a longer distance between the ground station and satellite data, we have another satellites in the middle to reduce the distance, and this send the data to the another satellites, and then from another satellite, this data comes to the ground station. From ground station, we are getting the satellites image, and these satellites image afterward, we put these satellites into the GIS software, into the computers, when different algorithms of classifications are available for analysis, classification, and finally we are getting image. So today our entire lecture is revolved around these A, B, D, E, and F, these steps. This we will learn today, inshallah. So we will start from A, and we'll discuss this one by one. So A is, for example, is the elimination source. So the first requirement for remote sensing is to have an energy source to eliminate the target, unless the sense energy is being emitted by the target. This energy is in the form of electromagnetic radiation. A very simple example: if you are at night, you cannot see anything, but when you open your torch, it emits electromagnetic radiation. It emits light. So this light goes to that object, and then after interaction with the object, this light goes back to your eyes, which is a kind of sensor, and then you can see that object. This is also the same thing. For example, the satellites, which are passive satellites, that's only work during the sunlight. So we need energy source, which is the sun, which is we call electromagnetic radiation. So as you know that this thermonuclear fusion on the surface of the sun is a continuous spectrum of electromagnetic radiation. So this electromagnetic radiation, we also call it light. This 6,000 Kelvin temperature of this process produces a large amount of short wave length radiation that travel to the vacuum of space at the speed of light. So sun continuously emits the electromagnetic radiation, and these electromagnetic radiation is coming towards the Earth, but before it has interaction in the atmosphere, and some of the radiation go back. We'll discuss in detail after that, and some are passes through. So the radiation which pass from the space, that reaches to the grounds, and the ground, it has again interaction with the water bodies, with the solid particle, that's different object on the surface of the Earth, and then it reflects back from the Earth, again interaction in the atmosphere, and then it finally reaches to the sensor, which is present in the satellite. So these Earth may reflect some of the radiation directly back out to the space, or may absorb the short wavelength radiation and then re-emit at a longer wavelength. So that's one of the, for example, source. A little more detail, but the physician know much more, that these electromagnetic radiation, which we call it basically light, this consists of an electric field, which varies in magnitude in a direction perpendicular to the direction, and which the radiation is traveling and the magnetic field oriented at a right angle to the electric field, and both these field travel at a speed of light. So actually it is light. So you don't need to confuse electromagnetic radiation or light, and these are same thing. So we are using different words for this. But in this radiation, two things are very important. But like the first one is the wavelength and frequency. So the wavelength is actually, if you can have a look to this shape, is the distance between these two successive crests, and frequency is the number of cycles passing through a specific area. For example, the wavelength is the length of one cycle, which can be measured like this, which can be measured between two successive wave crests. And wavelength is, that's represented by letter lambda. And also wavelength is measured in meter. You will have this in meter, or maybe in nanometer, or maybe in micrometer, or maybe in centimeter. Frequency refers to the number of cycles passing a fixed point per unit time. So frequency is normally measured in hertz, equal to 1 cycle per second, and various multiple hertz. So wavelength and frequency are related by this formula. That's actually the formula of that. But these two are inversely proportional to each other. For example, if a radiation has a longer wavelength, this means that this radiation will have the shortest frequency. So if a radiation, for example, have a shortest wavelength, it means it has the highest frequency. So two things can be noted in this. If it is how high wavelength, higher wavelength, it will have shortest frequency. But if it have lower wavelength, it will have high frequency. So the other thing which you need to be noted, if the radiation have a higher wavelength, it will travel more. But if it have a smaller wavelength, it will travel less. So that's, we will discuss later on. That's the reason that some of the radiation cannot reaching to the ground, and it remain into the atmosphere because of the shortest wavelength. And the radiation which reaches to the ground, this is only because of having longer wavelength. So that can be noted. So if you can have a look to the electromagnetic spectrum, it is normally composed of gamma rays. See, after gamma rays we have X-rays, and after X-rays we have ultraviolet, and after ultraviolet we have visible spectrum, and visible we have infrared. After infrared we have the microwave, and finally we have the radio waves. So if you can have a look to this graph, this is frequency. So the gamma rays have the higher frequency. This is a frequency chart, and this is actually wavelength. So gamma rays have the high frequency but shortest wavelength in the entire electromagnetic spectrum. If you come to the upper part here, the radio waves has the higher wavelength, but it has the lower frequency. So this need to be understand. If you understand this chart, In this case, gamma rays have the highest frequency, followed by X-rays, ultraviolet, visible, infrared, microwave, and radio wave. And here in this case, gamma rays have the shortest wavelength, followed by the X-rays, visible, infrared, microwave, radio wave. So the question arises that yes, sun emit um, um, gamma rays, and sun also produce X-rays, and sun also produce ultraviolet. So these radiations can also be whether these are available for remote sensing. So in remote sensing, majority of the radiation which are available for us, it starts from the violet, and then infrared, and then visible and infrared microwave radiation, because these radiations are coming to the earth. As far as the ultraviolet has some specific, we'll discuss later on. The gamma rays, because of the shortest wavelength of the gamma rays, it remains in the atmosphere, so it cannot reach to the ground, maybe in the space. The second is after gamma rays, X-rays. X-rays also have the shortest wavelength after the gamma ray, and also that's the reason that it remains into the atmosphere and cannot reach into the ground. After that, ultraviolet also have the third shortest wavelength, but we have the ozone layer. We'll discuss this in detail, which block the ultraviolet radiation. So we have then the visible spectrum, which we can see with our eye. The visible, we call this because it's within the sensitivity of the human eye. We can only see the visible color. This reaches to the ground, but we'll discuss. And infrared also reaches to the ground, microwave reaches to the ground, and radio wave. So in majority of the remote sensing, we are using the visible, infrared, microwave, and radio. These are available. We are using this specifically when we are talking about the passive, a natural available light. Although we can make the gamma rays or X-rays artificially, but not naturally. It's remaining in the atmosphere. So the light which our eyes, our remote sensing can detect, is the part of visible spectrum. That's the interest of our lecture, that we can only see the visible spectrum. So it is important to recognize that how small the visible portion is relative to the rest of spectrum. So there are a lot of radiation, as I told you, around us is invisible to our eye, but can be detected by other remote sensing instrument and used to our advantage. The visible wavelength cover a range from approximately 0.4 to 0.7 micrometer. The longest wavelength is red and the short is violet. So the question is that we have a lot of radiation. We have infrared radiation, we have microwave radiation, we have also the radio wave radiation, but we cannot see. So it's only because that it cannot fall in the sensitivity of the human eye. But for infrared sensor, we can even develop a sensor which can detect the infrared radiation, which cannot be seen by the human eye, but can be detected by the sensor. Even for microwave, we can even detect a sensor. We can develop a sensor which we can detect. So that's actually the meaning that we can only see the visible spectrum. So if you see the visible spectrum, we have violet. It starts from violet. So that's also because we call it ultraviolet. So in the visible spectrum, the shortest wavelength is has the ultraviolet. So it's actually ultraviolet, like the color is violet, but ultra, so it's beyond. After the violet color, we have the green color, and that's have the shortest wavelength. No, sorry, blue color. Blue have the shortest wavelength. And after the blue, we have green, and then we have red, and then in yellow we have red. So these green, red, or yellow, these are actually the primary color. We call it primary just because all the other colors are the results of combination of these three. So we also call it primary color. So as I told you that in the visible spectrum, which is important to us, blue, green, and red are the primary color or the wavelength of the visible spectrum. So they are defined as such because no primary color can be created from the other two, but all other colors can be formed by combining blue, green, and red in various proportions. So all the other color can be made. So if you can have a look in this visible spectrum, as I told before, that this is the ultraviolet, and then green. The shortest wavelength have ultraviolets. You see here the shortest 0.4. After that, the blue color has 0.446 micrometer of wavelength, and then we have the green, and then we have blue, and then we have yellow, and then we have red. This is actually the visible spectrum that we are using in remote sensing. And you need to know about this because satellites images, which when we download, it's actually in the form of different band. So a specific band represent a specific type of wavelength of a color. For example, one of the example which we'll also discuss tomorrow, band 2 in Landsat 8 satellites image, I think normally represent the green, I think the blue, no, the green color. And then band 3 represent this red, and then band 4 represent the red and yellow, and then red, and then band 5 represent, or band 4 represent the infrared. So every band represents a specific wavelength of a color, specific wavelength of color. So that's you need to know. And then when you we cannot work with a single band. So when you can see it's in the form of black and white image, but when you combine these bands, you will have then a colorful image of a colorful satellite image. Then you can visually even interpret different information. So that's the story behind it. So after the visible, we have the infrared portion. So the next portion of the spectrum is the infrared, which has the wavelength from approximately 0.7 micrometer to 100 micrometer. So more than 100 times as wider as the visible. So after that, infrared radiations come. So we cannot see infrared radiations, but that can easily be detected by the sensor which we have in the satellite. So, and in the infrareds, we have a mid-infrared, and then the middle, and then infrared. So the region can be divided into two categories based on the radiation property, like reflected infrared and the emitted or thermal infrared radiation. Thermal infrared radiation is something like, for example, it absorbed by the objects, and then it's re-emitted in the form of thermal radiation. We will also discuss later on. So radiation in the reflected electromagnetic region is used for remote sensing purpose in a way very similar to radiation in the visible. So the reflected infrared cover wavelength from 0.7 micro to 3 micrometer. The thermal infrared region is quite different than the visible and reflected electron, as this energy is essentially the radiation that is emitted from the Earth's surface in the form of heat. So this is actually the radiation which gives the heat to the objects or any object on the surface of the Earth. So the heat which is re-emitted from the body, that's actually kind of thermal infrared radiation. So nowadays we have a sensor which even detect the thermal infrared radiation, and that's one of the reasons that we can detect even wildlife during the night. So if you fly or drone or aircraft on the forest area, so the animal body emitting the thermal infrared radiation, and this sensor can detect these emitted thermal radiations, and this can be, and that's the reason we can even detect humans or maybe animal or maybe other our vehicle, whatever which emit heat. This can be detected by the thermal sensor. So the last is the microwave radiation. So the portion of the spectrum of a more recent interest to remote sensing is the microwave region from about 1 micrometer to 1 meter. So this covers the longest wavelength used for remote sensing. The shortest wavelengths have properties similar to the thermal infrared, while the longer wavelength approaches to the wavelength used for radio broadcast, specifically the radiation which are using for the radio purposes. That's actually a microwave radiation. But majority, as I told you, that in satellites, we have two types of satellites. One is passive satellites, which work on the sun energy, sun radiation, sun electromagnetic radiation. That's, we call it passive satellites. But we also have active satellites, for example, the satellites emits its own light from the space, and this light's coming to the ground, and then it reflect back, and then reflected light is detected by the sensor. So majority, for example, the space-borne active satellite has this microwave radiation just because of the highest wavelength. So if when a radiation have a highest wavelength, it will cover longer distance. If radiation have a shortest wavelength, it will cover a very smaller distance. So that's actually the reason that in the electromagnetic radiation, the gamma rays have the shortest wavelength, and that's only the reason that it remains in the space. It cannot reach to the ground. And in the electromagnetic radiation, the microwave have the longest wavelength. So that's why, because of the highest wavelength, the radiation is reaching to the surface of the Earth. So that's one of the reasons that we are using microwave radiation specifically. That's further divided into P band, L band, S band. So if you can just have a look to the example of this space-borne radar grammetry, like the two satellites, what call it, that's actually these two twin satellites in which we are doing this radar interferometry or radar grammetry. These are using the tandemic satellites, one of the example, which both satellites are in the form of partner, and one is both of them are emitting lights to the ground and then reflect back, and then they are using some interferometry coherence techniques, and then it can be followed by a phase wrapping techniques to estimate the height of the surface that you will get microwave sensor. So now then that was actually the first portions of our presentation, like the electromagnetic radiation. The second is, for example, when this radiation coming to the atmosphere. So what happened when it reaches to the atmosphere, when it will come in contact in the atmosphere? So what happened actually? That's the second part of the lecture. So before radiation used for remote sensing reaching the Earth's surface, it has to travel through some distance of the Earth's atmosphere. So the atmospheric scientific expert know that in the atmosphere there are present, for example, particles or gaseous in the atmosphere. And these gaseous particles or atmospheric affect the incoming lights radiation. So two kind of effect taken place like these are caused by a mechanism of, we call it scattering. Scattering takes place and absorption takes place. So some of the radiation is absorbed, and some of the radiation, for example, some of the radiation is absorbed by the atmospheric particle, or and some of the gaseous, and some of the radiation is scattered, redirected in the surface of the Earth. But you know that we cannot see the interaction of ultraviolet the X-rays as well as the gamma rays, which is in the space. But we can only see the visible spectrum, and due to the smaller wavelength of the blue color in the visible spectrum, it's scattered in the atmosphere, and that's one of the reasons that the sky looks blue. So scattering occurs when particle or large gas molecules present in the atmosphere interact and cause the electromagnetic radiation to be redirected from its original part. So for example, the electromagnetic radiation is coming from the sun, and it has interaction with the particle which are present in the atmosphere, and these atmospheric particles are gaseous redirected this electromagnetic radiation. In this redirection into different direction of electromagnetic radiation, that's actually called scattering. So how much scattering takes place depends upon the several factors, including the wavelength of the radiation. So as I told you that it's mainly related to the wavelength of the radiation, and also the abundance of particles, gases, and the distance of the radiation travel to the atmosphere. So actually three kinds of scattering takes place in the atmosphere. The first is we call it ray light scattering. So ray light scattering actually takes place in the upper atmospheric portion of the atmosphere. So this actually takes place when the particles are very small compared to the wavelength of the radiation. When particles are comparatively small as compared to the wavelength of the radiation. So this could be particles such as, for example, small peaks of dust or nitrogen or oxygen molecule which is present in the atmosphere. So ray light scattering causing shortest wavelengths of energy to be scattered much more than longer wavelength. That's ray light scattering is dominant scattering mechanism in the upper atmospheric portions. Yeah. The fact that the sky appears blue during the day is because of this phenomenon. This is one of the reasons of the scattering of the blue color, because of the shortest wavelength in the visible spectrum around the space, the sky looks like blue. So as sunlight passes through the atmosphere, the shortest wavelength of blue of the visible spectrum are scattered more than the other visible wavelength. So there are also scattering takes place of the other visible wavelength, but the scattering of the blue color is much more higher as compared to the other. This you can see the light is coming from the sun, and this is the space, and this is the redirection of the electromagnetic radiation in the atmosphere. In this redirection of the electromagnetic radiation into different directions, that's actually scattering and also ray light scattering. Second is takes place is mice scattering. Mice scattering is occur when particles are just about the same size as the wavelength of the radiation. So, for example, dust, pollen, smoke, and water vapor are common causes of the mice scattering, which tend to affect longer wavelength than those affected by the ray light scattering. So this is actually in ray light scattering, it was the particle size was smaller, and here in mice scattering, the particle size are just about the same as compared to the wavelength of the radiation. So also we have dust, pollen, smoke, and water vapor are common causes of mice scattering, which tend to affect longer wavelength than those affected by the early light scattering. So my scattering actually takes place in the lower portion of the atmosphere, where large particles are more abundant and dominant when cloud conditions are over. So that's the final scattering, which takes place, that we call it no selective scattering. So in no selective scattering is a scattering mechanism is called no selective scattering. This occurs when particles are much larger than the wavelength of the radiation. So in 2 tau, we have in red light, the particle size was smaller than the wavelength of the radiation. In my scattering, the particle of the size was just same as compared to the size of the electromagnetic radiation. But in no selective scattering, the particle size was bigger, I mean larger than the wavelength of the radiation. So my scattering actually takes place in the upper atmospheric. No selective takes place in the red light scattering takes place in the upper atmospheric, my scattering in the middle, and no selective takes place actually in the lower atmospheric portion. So the example is, if you can see, water droplets and large dust particle can cause this kind of scattering. So no selective scattering gets its name from the fact that all wavelengths are scattered about equally. So when all electromagnetic radiations are scattered equally in the same direction, that's actually produce white color. So, and that's the reason that now clouds or fog in the lower atmospheric portion looks white. So that's also one of the reasons that we are actually using white color during the summer, during the high temperature season. And also we kept our buildings white in color just because of the no selective scattering of all the electromagnetic radiation in a single direction. So that's actually because of the no selective scattering. So that's is actually the second part of this B part of the lecture. So Haris, can we take a break of 5 minutes, or we can continue? Or maybe somebody has a question, they can just ask, or what's your suggestion, Haris?
Sure, sir, it's up to you.
So we can continue.
If any participants have any questions, you can raise your hand and I'll unmute you. Okay, we have one question from Mr. Ibrar.
Okay, Ibrar Hussain.
Sir, what's the effect of scattering on remote sensing?
The effect of scattering on the remote sensing, yes. This also sometimes create a nice in the specifically when we detect the reflected light that's coming from the sun. Sometimes we have a blurred images or maybe a nice images, but still the remote sensing experts trying to using some filter to remove this nice. And this nice in majority of the cases takes place just because of the scattering. And the other, the clouds, that's also one of the effects. The cloud, due to the presence of cloud, we cannot see the satellites lying in the ground, and also the clouds produce the shadow. So that's when we are using these filter techniques or removing the noise. That's all because of the scattering effects in the atmosphere. Yeah. Right.
Anyone else with questions?
So we'll continue, Horace.
Sure, sir. Go ahead.
Right, we'll continue. Okay, so that was the second part. Actually, the story began Then the third is like absorption. Absorption takes place. So absorption is actually the other main mechanism at work when electromagnetic radiation interaction with the atmosphere. So in contrast to scattering, this phenomena cause molecules in the atmosphere to absorb energy at various wavelengths. So one of the example is ozone. This ozone layer is present in the atmosphere, which absorb the ultraviolet radiation, ultraviolet radiation, and that's stop the ultraviolet radiation that reaches to the ground. The second is the carbon dioxide and water are the three main atmospheric constituents which absorb the radiation. So the first, as I told you, that ozone serves to absorb the harmful ultraviolet radiation from the sun. So without this protected layer in the smear, our skin would burn and exposed to the sunlight. So that's one of the things. The second thing is the carbon dioxide concentration. As you know, that the greenhouse is one of the bigger challenge to the human. So the carbon dioxide comes after the industrial revolution after the 80s. The carbon dioxide concentration become of increase from 250 to somehow some 400 parts per million. So that's and this, what is the function of this carbon dioxide? This trap the back scattering of the specifically the infrared portion of the electromagnetic radiation. It cannot allow to the atmosphere the infrared radiation of the electromagnetic radiation, and just because of this, the Earth's surface becoming warmer day by day. So also carbon dioxide absorb also specifically the infrared radiation in the atmosphere. Apart, also we have some water vapor in the atmosphere, also absorb much of the incoming long wave infrared and short wave radiation. So the presence of water in the lower atmosphere vary greatly from location to location and in different of the year. For example, the air mass above deserts would have very little water vapor to absorb energy, while the tropics would have high concentration of water, and that's the reason that it have a high humidity. So the third, so I think, okay, the third is radiation, target interaction. So after interaction in the atmosphere of the electromagnetic radiation, some of the radiation reaches to the ground. So it reaches to the ground. So once the energy makes its way to the target, to the atmosphere, it interacts with the target, depends upon the property of both the target and radiation. So the radiation that is actually not absorbed in the atmosphere or not scattered in the atmosphere, this reaches to the ground. So the energy which reaches to the ground and with the electromagnetic radiation which reaches to the ground, which passes from the atmosphere, that's we call it incident radiation. So in the ground, there usually happen, these are absorption happen. So the electromagnetic radiation is either absorbed by different objects on the surface of the earth. Either this electromagnetic radiation is passes from that objects, or this electromagnetic radiation is reflected from the object. So what the remote sensing expert actually using the reflected bouncing back of the electromagnetic radiation from the surface of the earth. So the electromagnetic radiation which reflects from the surface, it has again interaction in the atmosphere, and then this reaches to the ground. This reaches to the sensor which is present actually in the satellites. But some of the radiation which is absorbed by the objects, this is re-emitted in the form of thermal radiation, which we call it heat energy. So this is also available specifically if you have a thermal sensor in the satellites or drones or aircraft. This can also be detected by the sensor. Yeah. So actually, three things happen in the ground: absorption, transmission, and reflection. But the fourth is re-emission, like in the form of the thermal radiation. So absorption actually occur when radiation is absorbed into the target. Transmission occur when radiation passes from a target. Reflection occurs when radiation bounces off from the target and redirected. So in remote sensing, actually, as I told you, we are interested in reflection. So two kind of reflection actually takes place. One is specular reflection, and the second is diffuse reflection. Specular and diffuse reflection. So in specular reflection, actually, the light is emitted from, or light is reflected in one direction. So the light is coming and light goes back in the same direction. The example is a road, specifically the smooth places. And also if you take an example of a mirror, the lights come and then reflect back in a single direction. That's actually a specular reflection. But in a diffuse reflection, the light is coming, just an example of a canopy of a tree. And these lights come from the sensor and then redirected this light in different directions. That's actually a diffuse reflection. But from some object, there is a combination of specular reflection as well as the diffuse reflection. So there is a kind of a middle level reflection, a combination of diffuse and specular reflection. So because of the different reflections, diffuse, specular, are in the middle, we have actually identifying different objects on the surface of the Earth. So because of different reflection, kind of specular and diffuse, and different intensity of electromagnetic radiation, a different wavelength of electromagnetic radiation, we are differentiation between different objects. But for example, if there is a reflection of all the color, just an example of white, so we can differentiate what is actually in the white color. And also in absorption, if all colors are absorbed, then it produces black color. We cannot identify. So also I will give you an example of interaction of the electromagnetic radiation with the trees, like in the leaves. For example, I will give you an example of how interaction takes place. So the light is coming, specifically the electromagnetic radiation coming, the visible light. So as you know, that a chemical compound in the leaf, call it chlorophyll. So the function of the chlorophyll, you know, the botanists know, to strongly absorb the radiation in the red and blue wavelength. So in the visible spectrum, we have red and blue. So these red and blue radiation is absorbed by the trees or the leaf of the tree, but reflect the green color. And that's one of the reasons that we can see leaves or tree in the form of a green color. Because of the reflection of the green color, we can see the trees green. But in the season of autumn, you know, sometimes the leaf looks like reddish in color. It's just because the leaves become dry, the chlorophyll contents become weak, so the absorption of the red color is weak, so it reflects a little bit the red color as well, and there's also the leaf become yellow reddish in color. So leaves appear greenish to us in summer when chlorophyll content is at maximum. So in you know, if you combine the spectral response of the vegetation in different season, in summer it will give you the highest response. So it's only because that the chlorophyll content in the summer is at the highest. In autumn there is less chlorophyll in the leaf, so there is less absorption in proportion and proportional more reflection of the red wavelength, making the leaves appear red or yellow. So the internal structure of healthy leaves act as an excellent diffuse reflector or near infrared wavelength. If our eyes are sensitive to near infrared, tree would appear extremely bright to us. So the internal structure that's in vegetation, as I told you, of the healthy leaves is an excellent diffuse reflection of near infrared wavelength. And that's one of the reasons that forester or vegetation is using the infrared radiation. But we cannot see the infrared radiation. If we have the sensitivity, the trees would appear extremely whitish to us as compared to the greenish. So in fact, measuring and monitoring of near infrared reflecting is one way that scientists determine how healthy vegetation may be. That's which we are using due to because of different reflection of the infrared radiation. The second, for example, the interaction of the electromagnetic radiation with the water. So longer wavelength visible in near infrared radiation. So this is different. Here, the longer wavelength visible in near infrared radiation is absorbed more by the water than the shortest wavelength visible spectrum. So you know that in the visible spectrum, the blue color is they have the shortest wavelength, and green and red color have the longer wavelength. So the water absorb the longer wavelength, the red as well as the green, and reflect the shortest wavelength in the visible spectrum. And that's why the water looks to us bluish. But sometimes there is a green algae present, or maybe some vegetation present, and also then a reflection of green color also takes place in the water. So sometimes then the water looks also greenish in color to us. So, but there is many things involved. For example, chlorophyll and the algae absorb more of the blue wavelength and reflect the green, making the water appear greenish in color than algae. The topography of the water, like rough, smooth, floating material, can also lead to complication for water-related interpretation due to potential problem of specular and other influence on the color and brightness. So we can also see from these examples that depending on the complex makeup of the target that is being looked at and the wavelength of radiation involved, we can observe very different responses to the mechanism of the absorption, transmission, and as well as the reflection. So finally, there are two things involved. One is reflection. In reflection, two things are involved. One is specular reflection, and the other is diffuse reflection, or maybe in the middle of the reflection. These things are known. And the second is the property of the objects of the surface of the earth and its internal mechanism and different reflection of wavelength of a electromagnetic radiation in different intensity. We can differentiate different objects or different phenomena on the surface of the earth. And that's actually the classification algorithm is actually doing, because when you take a sample from a water body, you will have different reflection, different wavelength of color. If you can take a sample from the forest, it will be different. If you can take a sample of a barren land, it will also be different. If you can take a sample from the built-up area, it would be different. So because of this different response of the electromagnetic radiation at a different wavelength, we can differentiate between different objects on the surface of the earth. And that's actually the classification algorithm actually doing. And then they are using some regression or some parametric classification or non-parametric classification. That's actually the classification algorithm doing. So spectral response is very much important. So by measuring the energy that is reflected or emitted by the target on the Earth's surface over a variety of different wavelengths, we can build up a spectral response for that object. So by comparing the spectral response pattern of a different feature, we may be able to distinguish between them, where we might not be able to if you only compare them at one wavelength. So if you just take one band of a one wavelength, it's not possible to differentiate between the different objects. But if you take all the bands of different response of different wavelength, then it may be possible to differentiate between different objects. Just if you can have a look to this graph here, just take the example of vegetation. So this is the reflectance, and this is blue band, and this is the green, this is red band. So here you can see the response of vegetation, like the green color is not that much separable, but if you can see in the near infrared portion, the response of the vegetation is quite high. So, but if you can see the line or the graph of the vegetation, it's quite different as compared to the dry soil, wet soil, clean lake, turbid river, and other things. And also, if you can have a look to the example of the dry soil graph, it's also different, and the turbid river water is also different. So because of this different recording of the energy by the sensor, different wavelength, we can actually differentiate between different objects using the satellite images by applying a variety of classification algorithm. Also, you can here is also the same example. Yeah. So knowing that's, for example, water and radiation may reflect somewhat similar images but are almost separate. So knowing where to look spectrally and understanding the factor which influence the spectral response of the feature of interest are critical to correctly interpret the interpretation of electromagnetic radiation with the surface. Okay, so that's actually the third part. Like the first was the electromagnetic radiation, which was coming from the sun, like the gamma rays, X-rays, ultraviolet, visible, microwave, and then radio wave. The second part was the interaction of the electromagnetic radiation in the atmosphere, where usually scattering takes place and passing. The third was the interaction of the electromagnetic radiation with the ground. Then absorption happened, reflection happened, and some more electromagnetic radiation is passed from the objects on the surface of the earth. So then the reflected light usually go back into the atmosphere. But after reflection of the light from the object, it has again interaction in the atmosphere. And this is also one of the questions from, I think, from Ibrar, that what is the effect of this scattering? And sometimes we have blurred images, some we have night see images in the sensor, and there's also the physicist using different kind of you call filters in the satellite sensor to remove, to decrease the scattering, the different scattering effects of different objects of the electromagnetic radiation. So this is actually the four recording of energy by the sensor. After the energy has been scattered by or emitted from the target, we require a sensor remote, not in contact with the target, to collect and record the electromagnetic radiation, mainly of two types. So that's also we discussed too, that satellite is just a carrier, it's a platform. But within the satellites, you have a camera or maybe a sensor that detect the reflective light that's coming from the Earth surface. So that's actually of two types, as also discussed, that is passive sensor and active sensor. So passive sensor actually work on the naturally available energy. That's actually the sun. The sun emits the light that's coming to the earth, then it reflects back, and these reflected lights is actually detected by the sensor which is present in the satellite. The second is actually the passive sensor, which, as I told you, specifically the glass eye-set satellites, pandemic satellites, and some other sensor which are specifically using for the digital elevation model or 3D mapping. That's actually using its own energy source, specifically in the microwave electromagnetic portion. This emits its own light. The satellite emits own light to the ground, and then it goes back, and then it detected by the sensor. So there are a variety of techniques which they can calculate the height of the your elevation of the surface, because sometimes they only measure the time difference, for example, the time difference. So if you have the time difference and you have the speed of light, you can even calculate the elevation of any object on the surface of the Earth. This is, so the sensor can be divided on the basis of passive and active. And the second is based about mainly about 3 types, like ground ball, which we are using in the ground, and in the ground, one of the example, as I told you, that's actually the TLS, like terrestrial laser scanning. And also, if you just take your camera and you take a photo of any area, and then you put this image into software, you analyze this also kind of ground sensor. And the airborne sensor, we have this, second is airborne, we have the, for example, drone technology. A variety of drones are available, which can be flying on a variety of elevation heights from the ground, and also the aeroplanes, which we are using in the air. And the third one is the spaceborne. So the spaceborne, there is active satellites, and there is passive satellites. There is navigation satellites, so geostationary satellites. So there are different kinds. So these geostationary are Landsat, and these are, I would say, these are part of spaceborne satellites. And then we have this high jet plane and low middle altitude jet plane, or maybe even drone. This fall in the categories of airborne. And finally, we have the ground sensors. So these satellites are drones, or aeroplane, or etc., are just a platform. So inside of the platform, you will have a sensor which detects the reflected lights which is coming from the object. So this is the example of the sensor which is available. Okay, so that was a platform, airborne, spaceborne, and groundborne. So when these lights going back to the atmosphere, this is detected by the sensor, which is available either in satellites, or maybe in aeroplane, or maybe in drone. So these sensors detect these lights, and then these satellites, the energy, this is actually in the form of energy recorded by the sensor. This transmitted often in electronic form to a receiving and processing station, where the data are processed in the form of image or in digital form. So these data finally from the sensor reaches, for example, going back, and this can be sent to the ground station, which are actually present in the form of antenna, and from the antenna we are getting the data in the form of images. And this data further go to the GIS software, and where the GIS expert doing different kind of analysis for different applications. Yeah, that's really the final products. So after this, the sixth, when you have this data, for example, when you get the satellite image, you will have to put this satellite image into the computer, and by applying different classification algorithm, and we are processing, analyzing the data for different applications. The geologists using this data for their own application, foresters go with their own application, agriculturists go with their own application, and finally this data the final products comes in the form of classified maps. And these maps goes to the policy maker, and they are making different kind of, for example, decision to protect and conserve the natural resources or other things, or maybe some other support system. Yeah. So finally, as I told you, that you will have the satellites image, but a classified satellites image, which is actually the final products of the process of the remote sensing. For example, the final remote sensing process we choose when we apply the information we have to being able to extract from imagery in order to. So the 7 elements comprise the remote sensing process from beginning to the end. So this is actually the process is actually composed of the 7 elements. For example, the electromagnetic source. This is the elimination source. This is actually called this emit the electromagnetic radiation, and then it comes to the atmosphere. In the atmosphere, it has interaction. This is the second part, and then scattering happen, and then it reaches to the ground, the electromagnetic radiation, and the ground it there happen absorption, transmission, and reflection. So the reflection light goes back to the atmosphere. It's again had interaction with the atmosphere, and then after passing from the atmosphere, it reaches to the satellites where there are sensors present in the satellites which detect the light, and then these detected light in the form of what you call it energy or value. These satellites send back the data into the ground station. And from the ground station, we are getting actually the raw data in the form of satellites images. And then finally, these raw data enter into the GIS software, into the computer, and different experts belong from different fields. They are using these satellites data for their own application. And when we have the map, and this map can finally go to the policy maker, decision maker, or administration, which can be used for different purposes. So that's actually the conclusion or final topic of my presentations. That, for example, the remote sensing data, that's actually spaceborne, airborne, and groundborne. This come to the computer for interpretation or with the help of ground truthing, and then it comes to the classified map, and this final maps can be used by different people for different applications. So I think this is the end of my slides. So we'll have, if you have some question, you are welcome, and we'll have a short break. And after that, we'll do some, we will see some online website that how to acquire the satellite data, how to search, and how to download. We'll have another lecture probably of 1 hour maybe, or 40 minutes maybe. So after that, you will have to make your account, and you have to start downloading the satellites data for tomorrow presentation or work. So that's actually the end of my. Okay, Zahid, I think you have a question. Yeah, please, Zahid. Horace? Zahid is asking some question. Sir. If you allow him.
I'll unmute him. Go ahead, Zahid. You can ask your question.
Hello.
Yes. Wa salam.
Are you listening?
Yes. How are you?
Yes. Sir, I want to ask the question that the forests are being planted in these deserts as in the form of oases. So what kind of information we can get about their quality if we see that in deserts, as the drought nowadays and climate is changing, because of that, the water content in the leaves, content in the leaves, and the condition Can we collect these information
Yeah,
for
of
the
course.
millions of
Yes,
yes.
about the desert, you can collect a variety of information, okay? You can collect the information, temporal information about the rainfall, okay? So the rainfall data is globally available, okay? You can collect the temporal information of the land surface temperature, okay? For even for land surface temperature, it's available. We have a small lecture also. After that, we will show you the website from which you can download. Now we have the GRACE satellites from which you can even estimate the water table, and across the globe. Yeah, even you can estimate the humidity of a desert. So, okay, that how much moisture content is available on the surface of the earth, specifically in the deserts. Even the wind direction. So a variety of information can be used. So, and many people have published very quality research using the remote sensing, specifically for drought monitoring, climate, global warming, or something like that. So a variety of data is available across the globe, and it's free of cost. And we will show you one website or two that you can even download for yourself. This is our second, practical hands-on exercise.
Thanks, sir.
Yeah.
Would you tell the name of that website or?
That's our next presentation. Okay, the final presentation. Yeah, you will get this. Yeah.
Thanks.
Yeah.
Okay.
Any other question if somebody has?
Any other participants with the questions, just raise your hand and I'll unmute you.
So Haris, I think we will take a break of maybe 20 minutes, or what do you think?
Up to you, sir. How long do you want? Do you want 10 minutes, 15? Completely up to you.
Okay. So
how long would you like the break?
I think we will take some 20 minutes. Maybe I will pray and then I will be in 20 minutes. Okay.
20 minutes.
Yeah.
So we are back 150.
150 will be okay. Right. Okay. Yeah.
That's fine. Sure.
Yeah. Fine. See you then. Yeah.
Bye. Take care.
Yeah. Afternoon. So our next presentation is a kind of exercise, practical exercise. We'll have, for example, how to download different. Oh no, this is the same presentation. Wait.
Yes, this is the first one.
Yeah, this is the first one. Sorry. Yeah. I think I already shared, so I have to go for unsharing this. That's the problem. This is actually the presentation, but I made it. This is right now?
Yes, search and downloading free satellite data.
Yeah. So, okay. Okay, so the next is search and download free satellites data. So before, if you talk before in the 90s or 80s, the Landsat satellites is freely available, and this is taking continuously images. Images around the globe. And then after 2015, Sentinel satellite is totally downloading, taking satellites images across the globe. Digital elevation models are available for the entire world. And land surface temperature, as I told you, land temperature, rainfall, humidity, and a variety of data is available. So today we will discuss about how to search and download satellites data, free satellite data, Earth observatory satellite data, and some climate data for any area across the globe. So I would suggest, as you see, that you would make first started an account in the USGS website, that is the USGS Earth Explorer website. So if you open this, and but everybody will have to be registered. If you register properly, then you go with the login. So when you log in, then it's possible to search and download the freely satellite data that we will explain later on. So this is one of the sites, one of the very, very, very old and very good and very potential sites for downloading different kind of data. You will find satellites images, maybe you will find some aerial photograph, you will find digital elevation model, but some are freely available, some are commercial. So you have to pay for that, specifically for the high resolution satellites images. So everybody, you have to make an account. This is a part of today exercise. After 3 p.m. when we finish, so you have to start making your account in the Earth Explorer websites. I will also share this presentation at the end, so you can. So when you log in into these sites, when you make or when you register, then you can put your name, username, and password. You will be logging. So you can see this is actually the interface of the website, and there are a lot of search criteria which can be used. We'll do this practically, no, but before I will go pass through this presentation. So if you search criteria, if you just write your name here, just type your name and then the name of the place or the name of the village. And if when it's visible, like if you write here, for example, Vishak Patan name or whatever, address in place, it will be appear here. And if you click on it, it will be appear on the map. So when your place appear on the map, after that you have to search for the satellites images, different satellites images. So after that, you just go with the date range, for example, date for which date you want. So as I told you that Landsat satellites images is available from even 1975 up to today. This is the Earth observatory satellites. So up to 2015, Landsat up to Landsat 7 available, and after 2014 or 15, Landsat 8 satellites are available with 15-meter resolution. And after 2015, even a 10-meter resolution Sentinel satellites images are available, which you can download from this website. Today we will check this. So if you write the dates, and then you can go for the Landsats, and these are different series of the products of the satellites data, which are available on this website, but some are free, some are not free. Even land cover data are available, but you have to search, you have to dig it out, that what is available, what is not available, and what is your interest. So for example, here in the presentation, they click on the Landsat collections. This is the US satellites. And so screen is visible or not? Paris? I think I have to change the screen because this is not visible. So, okay. Share the screen, that's this one. Okay, so I think now it's visible, right? So after that, for example, search selection the Landsats, you can have these, and then this option will take place along with the date, like for example, L1, this is level 1 products, and path and rows and date and months and etc. And you can, select. But before downloading, you can just click on the overlay so that it may be visible, like the scene. So a single scene, you can see a satellite Landsat scene cover a very big area, a very large area of this place. Even it's visible, and then you can just go with the download options. And after downloading, you have to select the GTIFF format, which is like the highest size, like 844 MB size. You have to download this level 1 GTIFF data products. After that, you can choose and then you can download. So when you download the data, and then it will be in the form of bands like band 1, band 2, band 3, band 4. And today, all of you, for example, specifically the newcomer, will have to make an account, and you have to download a single scene of your area, either from Sentinel satellites or from Landsat satellites, because tomorrow we'll have to do practice of this scene, downloaded satellite scene. So after that, you can just go through, and we'll do this also practically. So let me open this website. So this is actually the website. Let me share this screen. This is the site. So this is, for example, actually the website of a USGS website. So I already have an account in this website, so that's why I'm in. So there are many things. The first things about the geocoder, if you click on this, then you can write address or place name. So for example, I'm writing here Islamabad, which is the capital of Pakistan. So let me, it will start. So it's, you see, it's no visible here. So if you click on it, it will be, you see, it is no visible. Islamabad is visible here. So so if you zoom out, there will be coarse resolution sensor. If you zoom in, it will be a very high resolution satellites. But unfortunately, these high resolution satellites data are not available. So it's a kind of layer of satellites images. So this can be acquired commercially, but specifically Landsat can be freely downloaded up to 15 meter, 10 to 15 meter resolution data can be freely available from this site. So I click on it, I write Islamabad, so it's here. After that, I want to go with the additional criteria. For example, date range, date from which date you want the satellites. If you just click, for example, I will write that I write this from 2010, for example. So, and 2010 and 9/2010, this is the start date. And then you can search end date, what will be the last date for, or maybe, yeah, I write 15. So no, this you put the dates in it, that from which date you want satellite scene. Second is you want that how much cloud should to be there, because cloud also create a very big problem in land use land cover classification. For example, if cloud is present, one of the problem, you cannot see what is in the background. And also the cloud creates shadow, which also I mean, you cannot see some information in the shadow. So you have to select it, that how much shadow you want, 50%, 100%, or maybe will, okay, I will select like cloud covering, maybe like something like that. This is, and then result per page, like 10, I mean, how much scene you want. So I just write 10, or maybe you can write 25 or whatever. You can change it. After that, you have to go with the data sets. So the variety of data available, like for example, aerial imageries are available, but these are not available for the entire world. So these are only available for some places, maybe some in US or maybe some other places. So I'm not sure if it's available for Uganda as well, but I would suggest that you can dig it out and you can search it out. The data, if it's available, it will be pure. If it's not available, it will not be. So this is another satellites, advanced very high resolution satellites, advanced very high resolution. These are available, but as far as I know, this will not also be available freely. This is also another some data, and there's some commercial satellites orbit with 3 iconos up to 1 or 2 meter resolution, and also some spot commercial satellites, but you have to acquire this. So it's not freely available. You have to order them and they will send you the price, and you can further declassify data, you have to sort that what is these. Even some digital elevation models are available. For example, this can be downloaded from this website. If you just click on it, you can even download a digital elevation model of any area on the surface of the earth. Maybe for the entire Uganda, you will have the digital elevation model, or maybe the SRTM model. These are available. This is freely available. I know because I downloaded. We are using this for different applications. So it will give you elevation up to in 30 meter or 90 meter resolution. It will give you elevation of the area, and you can use for watershed purposes, for classification, for different, for geology, or for landslides, for different hazards or something like that, for buildings, for roads, for etc. This elevation model has great potential. This is available. So this is from SRTM. This is also active space-bound center, like shuttle radar topographic mission was done, and they did. Digital line graphs, maybe digital maps, some available, natural altas, and you have to search. You have to search for. There's also some data sets and also some others, and land cover data are available. For example, global land cover data are available. So these may be generated globally by some organization, and that's uploaded, and these are also available. So what we are talking about satellites, remote sensing today. So we are more interested in the Landsat satellites. So if you click on Landsat, there are a variety of Landsat legacy, Landsat collection, Landsat 2 atmospheric, Landsat collection 1, 2, and Landsat collection 2, 3 series. You have to search on internet. If you just write the name, you will find detailed information about which kind of Landsat data is it. For example, level 1, level 2, level 3 products. This is some type. The pre-processing steps were already done by this US Geological Survey. So you don't need to do with the pre-processing, like, for example, the georeferencing again, or georectification again, or maybe some atmospheric correction, something like this, was already done. So in this case, for instance, for example, I'm selecting maybe 4 to 8. This is not, let me check. This is also, I would say, this one, this Landsat collection 2 level, if you select this Landsat 8. So as far as my experience, Landsat 8 was launched in 2014. So I don't think so that it will be available for 2010. But along with, because we selected the date from 2010, so we will select also the Landsat 7 with it, so maybe it will be available. And maybe the other Landsat 17 mission on data. So this is a message from them. Data will not be acquired after April 2022. Please visit this. This is a message that it will not be acquired. Maybe there is a problem in the satellite. So if you select this and thus you just click on results. So now it's started searching. You can see there are a lot of scenes available. So if you can have a look, this is a little not clear. Yes, so I would suggest that for Islamabad, this one is a little more clear. So for better visual interpretation, I will click on overlay. So just to have a look at how, so this is, for example, a scene which is available for, but still, I would say that there is a little cloud coverage. So maybe I will check another one. This one is loaded metadata. Okay, and what's about this one? We have to select an image which is a little bit clear visually. So, but still, you know, in Islamabad, many clouds are there. So it hinder much of information. So this is also, for me, this satellite scene is also not that much good. Maybe this one. Let me check. So, let me see this. But you can select this in the pre-search criteria that I need only that satellites which have less than, for example, 10% of cloud. This is other, but this one looks also a little. So there are. This is not bad, I guess. Okay, or maybe, but somehow you have to select a very clear scene, or you will have to go back and you have to go with the research criteria that no, I need a satellites which have very smaller amount of clouds. So you see, many details are hindered. So it has also a lot of clouds. Okay, so yes, maybe this one. So okay, so you can select any clear scene of your area, or maybe sometime you have to think about the time of acquisition of the satellites, because in the mountain area, sometime in the month of October, usually there are not present that much clouds. Yeah, but sometime in December, you know, it's the monsoon season. So if you are acquiring images during monsoon season, so it's clear that the ground will not be visible. So you have to select a season where the images are clearly available. So you can search, you can dig it out, different kind of satellites. When you select a specific satellite scene that, yeah, this is actually my scene and I want to download this, and then you have to go with the submit. Okay, so before, also the satellites contain some information. For example, if you click on it, load metadata, if you can have a look to these scenes, this is actually the information about satellites. So this is actually land cover Landsat 8, 08 consider. So maybe this image was taken at 2019, 08 and 30. So this image is normally, I think, taken in 30 August 2019. Yeah. And maybe this will tell you the process or uploading, like, or maybe this is the taken image that it was taken on 26 August, and that will be the process which was uploaded. So this is Landsat 8, and this is data acquired like in 30 August 2019. So this is T1 and collection of number, and this is the path and rows. Actually, the Landsat satellites images have path and rows collection of the entire globe. If you don't, if your area is not available with the name, as I type Islamabad in Pakistan, you have to know about the path and rows of your area. If you can even search your satellite scene of your expected area using in the path and row information as well. Yeah. Further, this is also target. This is, I think, path information. 105 and 037 is the path information. And there's level 2 products, and that you have many information. You have to have also this, when you download this, the georeference system is WGS 1894, and this is the center information that long of the upper corner, left, right information. So you will have different information as well in the form of satellite data. So you can specifically download for a specific time different satellite scenes. If you want to know about, for example, forest cover or maybe building that, okay, what was the positions, what was the status of the forest in 2000, and what is the status of the forest in 2010 or 2020. So you can just download 2010 satellites image and then 2020 satellites image, and you analyze both of them, and you will clearly see the difference in the. So there are different analysis you can do with some indices differences, or maybe some classification algorithm, or maybe post classification, change detection. There are a lot of techniques you can use. So you can temporally detect each and every object, its changing phenomena, and doing the time setting series analysis using the Landsat satellites images. So when you search, you just go with the submit standing request. So yes, and then I think you can subscription, create subscription, and after subscription you can I think some satellites can be no, that was, I think we did a little wrong, because we have to download directly. So I will do again, like for example, the data are loaded the internet. Okay, so these are the results, for example. And then here you have the option, for example, you want to download any scene of any date. For example, I want to download this one, this scene, and then you have to go here, this download option. You have to click on it. So after clicking it will product option, collection 2, level 2, bundle, and then I think you can just select, as I told you, that which one you want, or maybe this one, download products, or add to bulk, or maybe yeah, to bulk, and then I think it's possible to further go to the downloading option. So by this way, you can, I will share the final presentation that how to download, which I show you before. By this way, you can even download different satellite scenes. So this was somehow about the Landsat satellites. That's actually Earth observatory satellites. In these data that are available from, I told you, 1970s, or maybe a little earlier, or maybe a little further. These data are available. So the second most important thing that I want to highlight, that these are Landsat 7 data. So see, it start downloading here. After that, these are Landsat 7 data, and this, but you know, Landsat 7 has a problem, I know. So this has a kind of line blurs type. These all images, I don't know for Pakistan, if they are not visible from Landsat 7, but you can go for Landsat 6 or something like that. So this. So that's how you can download the Sentinel satellites images. After that, I would say again, if you want to go for data sets, so don't go for, if you want to download another one, so I would suggest to download Sentinel. This is also NASA radar and maybe some Sentinel satellites images. So I'm clicking on Sentinel here. This, and I want to know about the results. So these are the information about Sentinel, which that it belongs from the European Space Agency, and these have bands, and these have this and this. So you have to study all this information. So let me search some product for Islamabad about Sentinel. So after clicking on it, go to results. That okay. So there are a lot of scenes available of Sentinel even for Islamabad. So I really suggest Sentinel is a very good satellite, because it gives you information of 4-band with 10-meter resolution. So 10 meter is quite high. You can use for different applications, but these data are available after 2015, I guess, yeah, for the entire Earth, and you can detect anything. But yes, if you want to detect something which has the size smaller than 10 meters, So this will be a little problematic to detect using Sentinel satellites images. So you can search again, it's the same procedure, or just if you want to select this one, for example, just go for this overlay, and you know the scenes are available. It's quite a big scene. The Islamabad is covered, and maybe it switches to the Mansehra district in Pakistan, some other area, but you can search by yourself for Uganda or maybe for other Islamic countries from where the students belong. After that, you can just go with the download option. So download option, you can download the L1, find L1, and this, the bigger size one. That will be just, if you click on download, it will start downloading, yeah, and then it will be downloaded. So that what we search by using the name search criteria. We put only the name of that area, but maybe the names are not available. Then you have to know the path and rows. For example, the area where I'm working in the forest, it has path and row of 151 and 35. So that's, I know already, and you have also have to know about this. So let me check that no coordinates found. So it is that area. It's that area. So you can even search using the path and row information also about the satellites data. And then after putting the date, from which date you want to download the satellite data, and then you can search. So yeah, you can even search with the help of polygon. So I think in the previous 2 days, you will learn how to make polygon of any area or shape file. But if you have polygon of your area, like you can just click on polygon, and then I think address, path and rows, address. So I think this option, KML. KML is also available. Look at see. KML is, it's just file, just make a polygon on a Google Earth of your respective area, and just right click and save in the form of KML. So just you can then bring, if you save your KML anywhere in computer, just select it and bring it here, the area where you want to map, you want to download satellites scene. You can even also find this, that. So that was a little bit descriptions of the USGS website for downloading Sentinel or length data. So I really suggest that after the end of lecture, but I will also tell you some other things. At least you have to download a data of your respective districts or the respected area, because from tomorrow we have to start it processing that, how to process data and how to get information from these raw satellites images. That will be your objectives. Okay, so that is also one of the web information Earth Explorer websites. I think we'll go with some other sites. Let me open this. No, this is not the things. So let me. I will also add these sites. That is okay. The second, for climate purpose, as far as the as you told, one of the colleague trainee asked that how to acquire data for a deserts. So you can even download data for deserts from this website. This is actually a kind of climate engine. I think it's visible. It's visible for all of you, or maybe let me check. No, this is climate engine share. Horace is visible now. Okay. Okay. So this is another website from which you can download very variety of information. So if you can write, for example, here in the place and location. So I'm writing again, for example, Islamabad. So you go with the center of the map. You can write any place in Uganda or maybe other Islamic countries. Okay. So this is, you see the Islamabad appear here, you know, it's in a bigger size. This is the site. So when you, for example, when you see these here, after that, you have to start searching for the data, for a different kind of data. So, you know, there are a lot of variables available. For example, here you can see it's a remote sensing. So in remote sensing, you will have information about length at 5, 8, 9, reflectance, NDVI, vegetation indices. Actually, NDVI maybe will do a small practical, and it's very simple, but it gives you the density of the forest, that how the forest, it gives 0 value to non-forest up to 10 non-forest, and it further gives values to forest. So, but if you want some other climate and hydrology information, you will, if you select here climate hydrology, you will have this information, variety of information. I'm not that much experts in hydrology, but is, you know, this is drought even. I think who asked, Muhammad Haris asked the question. So you have to dig out, Haris. No, that was a question about some other. So you have to dig out, maybe you will find some information about drought. And this is some daily, monthly, terraclimate, reanalysis, these, and different kind of information you need. These are available. So this is daily temperature. Now we come to precipitation. So, you know, daily precipitation, precipitation data is available from different sources. Snow cover data is available. Drought, you know, use drought monitor. These are available. So you have to search for the area where you come from, if you are enters area. So hopefully you will find this information. North American drought monitor. So these are land surface, some information, and these are fire danger zone. For example, where there is it give you a kind of maybe a pre-indication of the fire across the globe, that where fire is possible, specifically in the month of June, July, maybe in Pakistan, but maybe also if you click on it and the fire zone, let me search wind values or something like that. And also beside climate, you can have a climate forecast data here. So there are different data available for climate forecast, like grid mate, 7 days globally and some Canadian drought, something like that. And also some hazards maps, also burn probability, wildfire risks to communities, earthquakes. So these are data are available here. So for example, hydrology, just have a group go through it. So how, for what you need the data? For example, I need precipitation in millimeter for the specific dates. So not sure if it works, but let's see, get map layer. If it's working or not, let me check. So I don't know what's happened. So there is some information that give me precipitation in millimeter of that, but I think I have to use control to scroll the map. I have to use some other source, like for example, map, or maybe menu. What is this? And sorry, map. And so let me check. So you can go for the download options. And he said that, okay, download selector region. So if you want to download of any, you make a rectangular of this. So this also appeared because I think I already selected Islamabad. So autofill file name, download map layer, download image. So if you want to download image or map of that area of precipitation, it will be downloaded. Or if you want map or maybe image option. So these are available. So I think these are map layer or maybe some image, or let me check. So processing request. So that's if you write on it, the image will be downloaded of the respected area for precipitation. But that's your duty. You have to search for different kind of information. So now see Islamabad is automatically filled with a rectangular block. So by this way you can download the data for your country, for your district, for any area across the globe. So a variety of data are available from this site. So this is also possible. So Climate Engine, I really appreciate. It's a very good site, specifically for the climatologists, for the atmospheric sciences, for the drought monitoring, for the agriculture monitoring, forest monitoring, etc. So a variety of information you will get from that website as well about this. After that, I would say there is also some public open some data. I just said today some sites. So let me search it. What is this? So that's actually sites. Okay, so that's actually the sites. Okay, I hope it's the sharing option is this one. Yeah, this is share. So this is actually the sites. There are a lot of other sites. It's not only the first site where you can download shapefile across the globe for any country. The geographical boundaries of world administrative boundaries for any country, or the shapefile. So if you don't know the shapefile of your country, you can just download from here, and you can put into the you can upload into the there, and then you can download the data of any area. So this is just for downloading the geographical boundary or world administrative boundary. So after that, I also had some other information. Let me check in the presentation. Some other, and I will also share this presentation so you will have at least. I was searching about the majority of students is from Uganda, so I was searching also whether the administrative boundaries are maybe at the seal level for Uganda are available or not. So I even why it's not possible to copy. Okay. So data dot wait. So wait. Okay, so that's actually Uganda administrative shapefile level 4 level. So even if you want to search for your specific country, I'm sure you will find information. For example, this is the entire Uganda. You will find information at a district level or tehsil level information of the shapefile. For example, if you want to search some Landsat satellite data, or maybe other data, for example, climate data, and you don't know the boundary of your study area, of your interest area, for example, boundary of specifically of your study sites. So you just even here, for example, let's find the go for the shapefile. So these are, for example, if you download this. So I didn't check, but if you download this, I'm sure that it will give you the geographical boundary at a district level in Uganda. These are available, but you have to dig it out. So there are also some other websites, many websites are available for downloading and searching satellites data. But as far as I told you that today you have to download at least Landsat or Sentinel satellites data. You have to make account. You have to make account, for example, in the USGS website, and at least you have to download Landsat or Sentinel satellites data by using this above tutorial, maybe, or of your study area, because tomorrow we will start some practical steps with it. So I have one colleague here, he's sitting with me. Maybe he will also show you one of the sites from which you can also download some information about different parameters, for example, about climate, some precipitation, drought. He will also show you one site, and hopefully you will also get some idea. And after that, I think after the presentation of my small presentation of my colleague, if you have any question about specific site, we'll go, and then it's you can start making account in the UGS website. So here I have PhD students who is working with me, and it's Faisal Khalid, and he will be sitting in front on my chair, and he will also show you. Faisal, you can just write the site here, okay, and it's visible, and you can talk with them, okay, right? Yeah.
Bismillah ar-Rahman ar-Rahim. This is Faisal Khalid, and I am working as a research assistant currently discharged at Shahid bin Nazir Bhattu University. And today is the talk about the G1. So let's and we click on the first one. Basically, G1 is a tool that displays the Earth science data from NASA satellite directly. First of all, you need to log into this. So I have already account. Yes, this is my account. We can download a lot of data about the climate, about the temperature from this website, from these tools. For example, if we just click on the observation, this will give the different data that will be appear here. There are different disciplines like atmospheric chemistry, hydrology, ocean biology, oceanographic, water and water cycles. These are the different disciplines. We can download the data about related to this discipline. Likewise, if we click on the hydrology, if we scroll down this, for example, we can download these data about the air pressure, air temperature, albedo, energies, evaporation, evapotranspiration, flooding, likewise soil moisture, snow, surface runoff, vegetation, water storage, and winds. So let's download some data. First of all, we will give the range. For example, we want to download the data from 2011 01 01 to 2012 June. سر په دې نه بدله اوس څنګه هایټ کی نمونه وداره نو دلته ښکاري نه سر دلته ښکاري نه سر چې دا دغه به نه سر صحیح دی خو دلته کې ماته نه ښکاري د لاندې د دې نه لاندې دغه لیکل Yes, thank you, sir. From here, we select a region of your study interest. We can zoom it here. For example, I want to study this is Pakistan, but if you don't know about your study area, then you have to select a shapefile from here. For example, if I enter the Pakistan, we can select our study of interest here by the name, but also we can select to drag or to draw here with this polygon. This is Pakistan. For example, if I want to download the data about the, let's suppose I want to download data about precipitation. When I click on precipitation, the different data related to precipitation will appear here. Yes. So these are the different types of data which appear here according to your requirements of the study. If you want to download monthly or millimeter per hour, you can also change his units from here. This is available, but you have need to care of some this point. If you give the range here, if you select this data, then we should need to give the range between the 2003 and 2020. This is very important. For example, if I want to download the data about the GPM data is available from 2014, and this one is available from 1997. And the spatial resolution, let's suppose I want to this one, and temporal I want to download the monthly data. Which this is the final data which we find, and we can change the units here, millimeter per hour, inches per day. So if you select all the requirements or click all the requirements of your data, just come to just plot, click on the plot of the data. Check. You can see here, this is plotting. Yes, this is the precipitation data, the whole country of Pakistan, and we can download from here. And for example, we download in the GeoTip and KMZ and PNG file. We can download in this downloading here. We show in folder. So paste here. This is the data about the precipitation from 2011 to 2012, and you can do and you can play any job in GIS with this data, and you can acquire the information about your study from this map. This is a shapefile. When we open this in GIS, we can play any job with this. So this is the one of the sites we can download a lot of data about the precipitation, temperature, rainfall hazards, like flooding and evaporation or transpiration. Thank you so much.
Okay, so thank you, Faisal Khalid, for a very good presentation and for showing him how to download a data of precipitation. So I think many questions of the participant will be clear. So I think, Faris, this is the end of our today presentation and some practical hand of exercise. Further, I can see some people have made some. Yeah, if we want to make account, what should we do in GUANI? So, Faisal, there is one question. If you want to make account, what should we do? There is one question. If you want to make account, what should we do?
Just log in with email.
Yes, yes. So you just have to log in with your email. So it's very easily possible. Zaid Ahmed, okay? So just use your email address and maybe a password, and you can maybe if they ask for some additional information, just add it. It's very simple. You can make account. Okay. So what does the collection and level mean? Okay, level means actually just type this level 1, level 2, or level 3 products. If you can just search even on Google, this actually means the processing, the pre-processing of the satellite's data. For example, the geometrically corrected data or maybe atmospherically corrected data. So as far as the level increasing, the accuracy will be increasing. So you don't need to do for the geometrically corrected processing of the satellite data, or maybe atmospheric correcting data. But this just write level 1 product or level 2 product on Google, you will find the detail of this information. So not visible, this also question. Also some other questions that kindly include the application of remote sensing in hydrogeology in your presentation. I think we have the presentation at the end. It's about hydrogeology, and also we have there is a separate talk. So maybe we will also request Dr. Shafiq and Dr. Ali, who is experts in hydrogeology, for adding a small presentation about the potential application of remote sensing and hydrogeology. And we have an expert of hydrogeology in our group, and he's Dr. Ali, graduated from Germany specifically in this field. Also for exploration of water reservoir and estimation, that's also belong to Dr. Shafiq and Dr. Ali. We'll talk with him and hopefully we'll add. Sir, is there any relationship between remote sensing techniques in determining the probable exploration playing detailed acquisition, procedure for exploration of HC means from? Yes. I think this is also possible. There is specific techniques. We have people or maybe Dr. Shafiq is also working on it. So we have lecture on it. So maybe at the end of this, when Dr. Shafiq talk about his remote sensing, so you can ask this question from him. He's also working on geology, and he's actually from a geology department. Yes, so I am busy and doing the activity, therefore join later. Okay, so can we get presentation slides set to our email? Okay, I will upload this presentation on a chat box. Haris, you can download or you can share this presentation with Ardoma Bala. Okay, so there will be no problem. So can we get, yeah. The next is your job is to.
You can email it to me.
Okay, I will email to you as well.
You can also drop
Yes.
it in the chat box if you want.
Fine, I will do both of them. Yeah,
At the
yeah.
end of the training, we would compile all of them. And
Yeah,
share
yeah.
with them.
So I think I can do right now, or maybe okay. Okay, but no, it's your job to make an account in Earth Explorer and download some satellite data of your respective districts, or maybe your respective area of any area you want, because tomorrow we have to process this satellites data. And at the end, I'm expected a complete project in the form of land use, land cover map. So yes, I will send to Horace the presentation, and he will forward this presentation to all of you. So please, so don't worry, it will be done. Okay. So I don't have your email, Jawad Ali, to everyone. Please email me also today and the previous also. So yeah, it's the job of Horace, and I think he will do this. Yeah. Okay, Horace. Huh? So this is the end. Yeah, from our sides.
Okay, sir. I don't think there are any more questions. I don't
Yeah.
see any hands raised. You have already read
Yeah.
out the questions in
Yeah.
chat. I
Yeah.
think that is it for today. To all the participants, you have already noted down the task given by Dr. Sami to you,
Yeah.
making the account, getting the relevant data of your area,
Yeah.
so it can
Yeah.
be used tomorrow for process. So kindly
Yeah.
keep up with the tasks, and we'll start again tomorrow exactly at 12 o'clock Pakistan time.
Right,
Thank you so
right.
much, Dr. Sami.
Right. Thank you so
See
much,
you
Haris,
tomorrow.
for helping. Yeah, thank you. Thank you.
All right, take care.
Have a good day.